I'm going to be solving the 2005 AMC 10A problem 23. So let's read through the problem. Let AB be a diameter of a circle, and let C be a point on AB with 2 times of AC equal to BC. Let D and E be points on the circle such that DC is perpendicular to AB, and DE is a second diameter. What is the ratio of the area of triangle DCE to the area of triangle ABD? So essentially we're trying to find the ratio of the area of this triangle right here to the ratio of the area of this triangle right here. So the first step in problems like these is to denote some value to a length we already know. So in this case, I denote AC, the length of AC, to be x. And so this means that the length of BC, using the information we're given in the question, is 2x. So we have x and 2x. So it also says in the question, let AB be a diameter. So AB is a diameter, and so AB equals 3x. And so if AB is 3x and it's a diameter, we know that the radius is going to be half of this diameter. So the radius r can be expressed as 3x over 2. So I'm going to rewrite something here. This can be written as 3x over 2, and I'm going to label the center of this circle to be O. And so if BC is 2x and this radius part, BO, is 3x over 2, it means that OC is going to be x over 2. Because 3x over 2 plus x over 2 is just 4x over 2, which is just 2x. So the next step in this problem, we also know that OD, or DO, whichever you want to call it, is also a radius. And so we can denote it as 3x over 2 as well, just like we did for BO. And we can also denote OE as 3x over 2. So we have all these values. Now we have to use them in some way. So something that I see immediately is that triangle DCE can be split into two other triangles, DCO and COE. And so those triangles have the same height. So I'm going to label this point as point F. So basically what I mean is that DC is equal to CF. And I know that because segment DF is perpendicular to segment AB, which is given in the question. And so because of that, we know that DC and CF both stem out from point C, and so they must be the same length. So now we can use the Pythagorean theorem to determine what the length of CD is. So by the Pythagorean theorem, DO squared is going to be equal to CO squared plus CD squared. And so we can rewrite this as 3x over 2 squared is going to be equal to x over 2 squared plus CD squared. So this is 9x squared over 4 is equal to x squared over, I forgot to write squared there, is equal to x squared over 4 plus CD squared. CD squared is then equal to 8x squared over 4, which is just equal to 2x squared. So this means that CD is equal to x root 2, taking the square root of 2x squared. So now this is very helpful. We have x root 2 as the value of CD. So essentially we can find the area of triangle CDO, and we can just double that because COE and CDO have the same area, and that will give us the area of triangle CDE. So let's first find the area of triangle CDO. So CDO, it'll be equal to x over 2 times x root 2 over 2, which is equal to x squared root 2 over 4. Now doubling this will give us 2 times of x squared root 2 over 4, which is equal to x squared root 2 over 2. So now we know what the area of triangle DCE is, and it's x squared over 2. So triangle DCE. So now we know this. Now, all that's left in the question is to find out what the area of triangle ABD is in terms of x, and then we can find the ratio and the problem will be done. So, to find the area of triangle ABD. So, something I noticed immediately while solving this problem and looking at it was that triangle ABD is similar to triangle ADC. Similar to triangle ADC by angle-angle similarity, because they both have a right angle right here, and also triangle ABD I know has a right angle because any triangle inscribed in the inside of a semicircle has to be a right triangle because it's an inscribed angle and stuff like that. So that's one angle that's the same, and then we also have this common angle in both triangles, and so therefore by angle-angle the two triangles are similar. So that means that the ratio of corresponding lengths is going to be the same. So AC to CD is the ratio of the short leg to the long leg. So it's x over x root 2. Now I know that this should be equal to AD over DB. So to find out what AD is, we can use the Pythagorean theorem one more time. So it should be the square root of x squared plus x root 2 squared, which is equal to the square root of x squared plus 2x squared, which is going to be equal to x root 3. So AD is x root 3. So this is equal, and I'm going to erase this just to save some space. So x over x root 2 is going to be equal to x root 3 over, I don't know, let's call dB as a for now. And solve for it in terms of a. So cross multiplying gives us ax equals x squared root 6. Simplifying this gives us a is equal to x root 6. So using that, we can say BD is equal to x root 6. And so now that we know what these lengths are, we can now find the area of triangle ABD. So the area of triangle ABD is going to be the base times height over 2. So x root 3 times x root 6 over 2, which is equal to x squared root 18 over 2. X squared root 18 can be simplified as 3x squared root 2 over 2. Because square root of 18 is just 3 root 2, so it's 3x squared root 2 over 2. And so this is ABD, triangle ABD. So now all that's left in the question is dividing this length by this length. So we do so x squared root 2 over 2 over 3x squared root 2 over 2 is equal to 1 over 3. And so the answer is C, 1 over 3.